Hello friends, in this video we will discuss the type of the system which involves the two equation involving two variables. So we have discussed the case 1 in previous video. In this video we will discuss the case 2. So there are two types of the cases, in which first case was one should be the linear, other should be the quadratic. In the second type both should be the quadratic. But in this type there is a case 2 which says one should be factorized. So means one equation can be factorized, and after factorizing it we will attain the two linear equations, and we will treat this system is equivalent to the two linear equations and one quadratic equations. Let's take an example. X square plus y square is equals to the 85. So this is a quadratic equation. So another quadratic equation is x square minus 6xy plus 8y square is equals to the 0. So we have written two quadratic equations, and here is the system of the two quadratic equations involving two variables. So to solve this equation, what we have to do, just factorize equation number 2. This is equation number 1, this is equation number 2. So we have to factorize this equation number 2. So let's factorize it. So for factorization, 8y square and 8xy square means the multiplication would become 8xy square. So from it 4xy minus 2xy. So when we multiply them we will get positive 8xy square, and when we add them we will get negative 6xy plus 8y square is equals to the 0. Now take the common factors. Here is x common factor, so here remains only x, here remains only 4y, here remains only, take 2 common factor, 2y is the common factor, here remains only x, and here remains only negative 4y is equals to the 0. Now take x minus 4y is the common factor. Now here remains only x, here remains only negative 2y is equals to the 0. So now we have got a condition where the multiplication of two numbers is equals to the 0. So first we have to make both equals to the 0. So either it should be equals to the 0 or x minus 2y should be equals to the 0. So we have got now three equations. This equation is linear, this is linear, and this is quadratic, and this equation is equivalent to the system of these two equations. So we will solve this quadratic equation with the help of these two equations. And now we have got a case where we are going to solve a system where there is one equation is linear and other is the quadratic. We have also discussed this in the previous videos. You can see the video in the cards. So to solve this video, let us make it in the standard form of the quadratics. Standard form of the linear equation. The standard form of the linear equation is y is equals to the mx plus c. So m is our slope, x is our variable, and c is our constant. C is the intercept in geometrical form. So x minus 4y. So you have to write in this term in the 4 in term of the y. So y comes the other side. It becomes y is equals to x over 4. Here y should be equals to the x upon 2. So we have got two linear equations from one quadratic equation by factorizing them. So we have written them into the standard form of the linear equation. So which is the standard form of linear equation is y is equals to the mx plus c. So m is the slope, x, c is your intercept. So it means we have to write this equation in this form. So we have written this equation in y is equals to, because this is the y is equals to. Now we have got a system where there are two linear equations, one quadratic equation. So to solve this system, what we have to do? We have to just consider two cases where x square plus y square is equals to the 85 and or y is equals to the x upon 4. This is the one system, and we will form another system which is x square plus y square is equals to the 85 and y is equals to the x upon 2. This is the another system. We will solve these two systems separately. The solution for these two equations or this system would be this union of solution of these two systems. So to solve this system, what we have to do, just put x upon 4, y is equals to the x upon 4 in this equation. So our system would become x square plus x upon 4 whole square is equals to the 85. If we put x upon 2 in this system, so it will become, so this will become x square. Now y is equals to the x upon 2, here is y square, so it should be x upon 2 square is equals to the 85. So this would become x square plus x square upon 16 is equals to the 85, because the square of x is x square, square of 4 is 16, and here x square plus x square upon 4 is equals to the 85. Take LCM as the 16, so here is nothing but 1. Table of 1 on 16 times, so this 16 will multiply with the x square, it will become 16x square. Table of 16 on 16 one time, so 1 multiplies with the x square, just x square is equals to the 85. Take 4 as the LCM, here is nothing but 1, so 1 divides with the 4 times, so 4 multiplies with the x square, it will become 4x square. 4 divides with the 4 one time, so 1 multiplies with the x square, it's just x square. 85. Now add them and multiply the 16 on the other side, because it divides on the other side of the equation. So 16 plus 1, it would be 17x square is equals to the 85 into 16. Now here it should be the 5x square. 85 into the 4. Now just try to simplify it. Table of 17 on 85. 5 times, it would work only 5 times. So just 1 time in here, just 5 times. So it would become x square is equals to the 5 into 16. So it would become 30, 3 goes up, 80. So it would become just 80. Now solve this. 1 time, 1 3 goes on the other side, 17. 4 into 17, it would become 4 7s are 28. 2 goes up, it would become 68. So we have got equations where x square is equals to the 80 and x square is equals to the 68. So to solve this, what we have to do, we have to take square root on the both sides of the equations. So take a square root on the both sides of the equation. First equation is, we will solve them separately. X square is equals to 80 and here x square is equals to 68. So we have got these two conditions. So x should be is equals to, take a square root, it will become positive negative 80. Take a square root, here will become positive negative 68. Fine. Square root cancels, it just x plus negative. Now what should be the factors of the 80? So it should be 2, 40 remains, 2, 20 remains, another 2, 10 remains, another 2, 5 remains. So it is the, we can write it as table of 4 20 times, table of 4 5 times, easy. So and here square root cancels, positive negative is 68. Now we want to solve the 68. The factor would be 68 is simply 4 into 17. Write it as 4 into 17. So here we can see positive negative, 2 comes out and 2 comes out. So 2 2s are 4, it would become 5. So one from one pair, one number just comes out. So 4 square root 5, here is positive negative 2 square root 17. So we have got two solutions for one equation, two solutions for another equation. So if we want to solve for this entire system, what we have to do, we have to replace these values in these values of the equations, these values of the y. So because this is y is equals to x upon 4, we have got these values from this system. So these values are for this system, this y is equals to x upon 4, and we have got these values from this system. So these values will be put in this equation. So let us solve them. So our x is equals to the positive negative 4 upon 5. So our y is equals to the x upon 4. There would be the two values of the y. First x is the positive 4 square root 5. Another value is x is equals to negative 4 square root 5. So these would be put in this system. And now this system. So to solve this system, what we have to do, we have to just put those values. X is equals to positive 2 square root 17. Another is x is equals to negative 2 square root 17. So these two values are for this system, these two values are for this system, this equation. So our y is equals to the x upon 4 and x is equals to this. So put x just 4 square root 5 upon 4, 4. So it cancels. Your y is just square root 5, means positive 5. Now here y is x upon 4. So your x is nothing but negative 4 upon 5. So just write negative 4 square root 5, just 4, 1, 1. So y is negative square root 5. From this system you can see our y is equals to the x upon 2, but your x is square 2 square root 17. So 2 cancels, y is just 17 positive square root 17. Here y is your x upon 2, but x is negative 2 square root 17 divided by 2. So it just y is equals to negative 17 but of square root. So we have got a solution set for respective values. So for value of the x, this value of the x, the y value is this. So the pair should be 4 square root 5. So it is the value of x. For this value of the x, value of y is square root 5. For this, value of the x is negative 4 square root 5. So value of the y for this value of x is negative 5 square root 5. Here it is 2 square root 17 and the answer for y is just square root 17. And here negative 2 square root 17, it is square root 17 of negative. So to write this solution set, we have got 4 certain solutions for this system of the equation which we are supposed to solve this system. So the solution set is first this value 4 square root 5, just square root 5. Another solution is negative 4 square root 5, negative square root of 5. And another solution is 2 square root 17. For this value of the x, we have got value of the y is just 17. So another solution is negative 2 square root 17 and just negative square root 17. So we have got a system of a solution set which contains the 4 pairs. This one pair, second, third and fourth. These 4 pairs can solve these quadratic equations simultaneously.